students, I'm your Komali Mam. In this session, I'm going to teach you the difficult and toughest topic, that is extraction of iron from hematite ore. From today, after a 15 to 20 minutes, this topic is not any more difficult for you. Extraction of iron from hematite ore. Why it is difficult? Because if you see this extraction in a blast furnace, there will be different temperature zones like combustion zone, fusion zone and reduction zone, slag formation zone. Different temperatures will be there. So student feel difficulty of this remembering this temperature. That's why today I'm going to teach you. After this video, you will solve any question. See here, see the questions. See the questions. See these reactions. How many reactions are there? Many reactions, right? Here I am showing you just few questions. You take any material which you are having, any textbook which you are having, you will be able to solve questions very easily. Within a less than 30 seconds, by seeing only, you will be able to solve the questions. Okay, let me start the session. Actually, iron extraction, I am going to teach you from hematite ore. Okay, what is the ore? Metal with the impurities, we call it as a mineral. Metal plus impurities, we call it as a mineral. From mineral, we get some profit, and if you do extraction, that is called as a ore. We have different types of ores, but iron, main ore is hematite. We can get more percentage of iron from the hematite ore. These are the secondary ores. Little speed I'll maintain because you can pause the video and you can see. So magnetite and limonite. Magnetite, what is the formula? Fe3O4. Limonite, Fe2O3, 3H2O. And siderite, FeCO3. And you can also see this is what? Fool's gold, FeS2. See, it is looking same like a gold, right? It is looking same like gold, FeS2. Fool's gold. Okay. Now, these all are the secondary ores. We are going to learn about the main ore, primary ore, that is Fe2O3. What is the name of Fe2O3, students? Hematite ore. Let's begin the session. Extraction of iron Fe from very easy. If you study directly, you may feel it is difficult, but see how easy it is. First step is crushing and grinding. What is this? Crushing and grinding. What do you mean by crushing and grinding is, we will take the ore and we will put in a jaw crushers and we'll make it into fine powder. This is, we will crush it, make a powder. And the second step is concentration. What do you mean by concentration? We will remove the impurities. How we remove? There are different methods like levitation, which is also known as hydraulic washing, or we can also do froth flotation, magnetic separation. But here we do a levitation, which is also known as hydraulic washing or gravity separation. Why this is? Write all these points. Take one rough notebook or one notebook you keep for chemistry classes, okay? Whatever I'm discussing here, you just write there. Levitation. What do you mean by levitation? We will flow the water so that all the heavier ore particles settles down. Impurities flow along with water. Okay, so that we remove impurities up to certain extent over. Then the third step is important. Here the next step, see the next step. First crushing, grinding over. Second concentration we have done. Third, if the hematite ore, it is having any impurities like siderite, SED, siderite. See, SEDARITE, siderite. SEDARITE, siderite. So, FeCO3 is the formula. What happens is, we heat it in the absence of air. We call it as calcination. What do you mean by calcination? FeCO3, it breaks into FeO plus CO2. This is a waste gas which goes out. We got FeO. Listen carefully, students. Calcination means heating the ore in the absence of air. When we heat this, it converts into FeO. This FeO will react with the impurities. Which impurities? Hematite ore will be having SiO2 as an impurity, silica as an impurity, sand as an impurity. Now this FeO reacts with this impurity and it forms slag. FeSiO3 is a slag. Okay, so what we have to do is, if this reaction happens, all the iron will convert into FeSiO3. We don't want this to be happen. Okay, now what we will do is, if it happens, all iron converts here. So we will do roasting. What do you mean by roasting? Heating the ore below its melting point in the presence of oxygen. Okay, once you do this, it converts into our hematite ore. So, in such a way, if any siderite is there also, we will do first calcination, then roasting, we will convert into which one? Hematite. Is that clear? Now, we will come to the blast furnace. Very, very important. Pay attention here. How I am going to do this. One diagram, little bigger one I will draw. So that writing reactions, it will be convenient. That's why little bigger I am drawing. Okay, little bigger. Simply like this, little bigger I am drawing. I'll tell you step by step. This is a blast furnace. Okay, here one cone shape, cup and cone shape arrangement will be there. Okay, through this cup and cone shape arrangement, we will pass charge. What do you mean by charge? Charge means hematite ore plus limestone calcium carbonate plus coke. See, so this is hematite, this is calcium carbonate, this is coke. These three together we will put in this blast furnace. Okay, once we put in this blast furnace, from down we will blow an hot, already heated, preheated hot air we will pass through this hot air. So from top this ore is falling down and coke, everything is coming like this, and from down oxygen is going. In a blast furnace we will see different temperature zones. I'll write this temperature zones, starting, reduction zone or zone of reduction. You can see reduction zone or zone of reduction. This is our first zone. Okay, low temperature, it will be around some 250 degrees Celsius to 700 degrees Celsius. Okay, here I am using degrees Celsius. In NCERT it will be given in Kelvin. Different literatures, different authors maintain little slight variation will come in the temperatures. You no need to worry. For example, down very high temperature, here very high temperature. This is called combustion zone. Combustion zone, total 4 zones. Okay, this is combustion zone. Its temperature will be around some 1500 degrees Celsius to 17 degrees Celsius. Few authors they mention 18, few other authors they mention 19 also. Okay, high temperature zone it is. So what happens when you put this charge. Then this coke slowly comes down, it falls down, and this blast of air comes here. So this coke reacts with this blast of air. Little down I would have drawn this, little here like this. Okay, this air comes here. This coke reacts with this oxygen, forms CO2. This reaction is an exothermic reaction. Around 393 kilojoule of energy will be released. Okay, it is an exothermic reaction. Heat will be released. Because of this heat, this temperature will be, they may ask you what is the hottest zone in the blast furnace. Which zone? Combustion zone. C plus O2 gives rise to CO2. Now these CO2 vapors go stop. Then here one zone will be there, that is called as fusion zone or zone of fusion. Fusion zone or zone of fusion. I will tell you why it is called fusion zone after some time. First, let me tell you what happens in this fusion zone. See, if you study like this, it will become very easy for you. This temperature zone will be around some 1000 degrees Celsius to 1500 degrees Celsius. See here 15 to 17, here 1000 to 15 degrees Celsius. Here what happens is this CO2 which is produced here, from top you are putting coke, it reacts with the coke and it forms carbon monoxide. It is an endothermic reaction, it absorbs the heat. So here high temperature will be there, here little less temperature will be there because it needs the temperature to reaction to takes place. That's why temperature difference came here. Got the clarity? And now carbon monoxide came. This carbon monoxide is it is a very best reducing agent. Ellingham diagram explained about this. Okay, I already uploaded. CO is the best reducing agent. This CO goes stop. It needs very less temperature. Around this temperature it is enough. So it reduces Fe2O3. From where it is coming Fe2O3? Because you are keeping from top. You are putting hematite ore. So that Fe2O3 comes here, it reacts with this CO and it reduces this hematite ore into Fe. And some waste gas will be produced. See here, CO2 is if through here you pass the hot air and here one outlet will be there. Whatever the waste gases produce through this, it will come out. Waste gases will come out. Okay. Now, done. This iron, here I did not balance the reaction. You can balance the reaction. Balanced simply. Now, whatever the iron we got, that iron is called as a sponge iron. Few they say sponge iron, sponge or sponge iron pronunciation or spongy iron. This iron is formed here. Actually, what happens is this iron, slowly it melt. It will be like not solid or it is not liquid. It like some semi-solid kind of structure will be there. What happens is this fusion zone is there, right? In a fusion zone, listen carefully. We are coming almost 70% done. In a fusion zone, whatever the coke is there, coke not only carbon dioxide it will reduce, it will reduce other impurities also. The continuation of this fusion zone reactions I'm writing here. Okay, continuation. If any manganese pyrolusite ore is there, MnO2, it reduces to Mn. If any phosphorus oxide impurities are there, it reduces to phosphorus. If any sulfur dioxide, sulfur, it reduces any silica impurity, silicon. So, like this, all these impurities will be formed in the fusion zone. Understanding? So, these reactions comes where? In a fusion zone. Now, what happens is, these iron, it's erased. Okay, this is combustion zone, right? Combustion zone, right? Step by step. If you want, you can rewind one more time and you can, C plus O2 CO2. So, here what happens, students? Here sponge iron is there, pig iron, sponge iron. It is slowly, it comes down. When it is coming down in a fusion zone, the temperature will be around 1500 degrees Celsius. There the melting of iron starts. Okay, still that melting, that semi-solid kind of sponge iron, it starts melting. The sponge iron, the name, because it will be like a sponge. How in a sponge that kind of hole, kind of empty gaps will be present like this. In that sponge iron also the gaps will be like that. Then what happens is, at this fusion zone temperature around 1500 degrees Celsius, iron starts melting, and now whatever these impurities are there, it goes and occupy that holes, voids of this sponge iron. Okay, mostly coke only, because we are adding coke, so much of coke we add because to get the CO, reducing agent. But what happens, whatever the left, everything will go and occupy this sponge iron, and this manganese also, phosphorus also, silica also, sulfur also will go and occupy, and that impurities, dirt, everything will go and occupy to that sponge iron, and that iron is called as a pig iron. That iron is called as which iron? Pig iron. That pig iron slowly comes, it settles down. Okay, now I'm going to the next page. Here I'll go to the next page and I will tell you a few more points. See here, first reduction, combustion zone, CO2 produced, it went to a fusion zone, there CO2 reacts with the coke, converted into CO. Now this CO goes into reduction zone. Why? Because of temperature. Less temperature is enough for it. It reduces Fe2O3 into Fe. That Fe mixed with the impurities, this iron melts around this temperature 1500, and it mixes with these impurities and it settles down. Slowly it migrates down, and we will collect here. Okay, down I'm not having a place here, so I'm doing the continuation. If down, if it is there, we will draw like this and we will show. All this is a pig iron. Okay, which settles down, we will put one outlet, this will come down of this, okay, like this, continuation like this. Okay, that we will collect all the pig iron. Got it? Here one more zone is there, that is called as zone of slag formation. What is that? Here name is fusion zone. Why? Because all are fusing sponge iron. Next one is combustion zone. Combustion, this one, what to say? What's this? Second one, slag formation zone. What is this slag formation zone? Is if you during this process, some impurities will be, are you understanding? Some impurities will be there. What are these impurities? Like silica, earth crust, siliceous impurities will be there. Now we will add limestone. What is the use of limestone? See here one more zone I am going to explain now. Here second, one more zone. So little bit I'll erase the screen. If you want to copy anything, you can please copy. Here second zone I am writing now. Third zone I'll erase. Okay, third zone I am erasing. To write the second zone, I can write outside, but if I write here, you get the more clarity. That's why I wrote here. Second zone is zone of slag formation or slag formation zone. Anything you can write. Slag formation. So this zone will be around the temperature of, this is 250 to 700. This is 700 degrees Celsius to 1000. Next one is 1000 to 1500. Next 1500 to 1700, 1800, that region. Okay, or 1900, like high temperature zones. Here, whatever the coke you are taking, calcium carbonate we are taking, that will break around this 1000 degrees Celsius temperature, and it forms CaO plus CO2. It breaks. CO2 is a waste gas. It goes out. This is our basic oxide. This is our flux. Why we are adding this flux? Flux is a substance which we add to remove the impurities. Now this CaO reacts with the impurity, siliceous impurity SiO2, and it forms CaSiO3. Questions will come from this. Siliceous impurity, calcium silicate. This calcium silicate means all the sand, dirt, that silica will be mixed with this calcium oxide and it forms a calcium silicate. Now not only this calcium silicate, if any other impurity is there also, it will mix with this slag and it will migrates down. See, down we already got pig iron, right? On the top of this, it will be settled. All the slag will be settled and we will separate the slag. All we will separate the slag. Clear, everybody? So can you, till now what you learnt, let's see the quick points, all points. First, 4 zones. What are those 4 zones? Tell me. 4 zones, tell me. Repeat everybody with this. Done. One more time. Combustion zone. What is happening in combustion zone? Short way I am writing. C plus O2 gives rise to CO2, high temperature zone. This CO2 is going up, and where it is going? It is going to the fusion zone. This CO2 reacts with the coke and it forms carbon monoxide. Endothermic reaction, little less temperature, around how much? Some 1000 to 1500. This CO needs very less temperature. It goes to which zone? Tell me, students. It goes to which zone? Reduction zone. It reduces the ore which is falling from top into Fe plus CO. So this is CO2. It goes as a waste gas. This is our sponge iron. This sponge iron comes here. If this coke reduces other impurities also, it will mix with all impurities. This carbon also mix and it settles down. That is called as a pig iron. Which iron? Pig iron. What do you mean by pig iron? Actually, why the name pig iron is, here more than 3% carbon impurities will be there. More than 3%. Carbon plus other impurities. Why the name pig iron is given is, starting days, they have used to put this iron which is coming in the that molds. That molds, they used to cast it in the form of that piggy shape used to get. That's why the name came as a pig iron. And a few others they mentioned, like some impurities, dirt will be added. That's why they have kept the pig iron name. But mostly they say that based upon the mold shape, piggy shape molds, this iron used to put, and they used to make it into particular shapes that looks like some pig kind of shape. So piggy iron, the name pig iron is given like that. And here impurity is what? SiO2. So this impurity we should remove. How to remove this impurity? That's why we used to add flux. How to add a flux? Calcium carbonate. Carbonate salts will, break around 1000 degrees Celsius. We get CaO. This CaO is our flux. It reacts with this silica impurity and it forms calcium silicate. Now in that blast furnace, if you see blast furnace, here we are passing air, hot air, here waste gas is coming out, here all pig iron is coming, pig iron, and here we are putting all the charge, and here slag comes out from here. This is slag which is having impurities. Calcium silicate is our slag. Clear? And here another super 2 points I will tell you. Okay, that is this Fe2O3 is reduced in where? Reduction zone, because CO is the best reducing agent. If any Fe2O3 is left which is not reduced in the starting reduction zone, that Fe2O3 comes down. Here coke is there, right? It needs high temperature around fusion zone and near to combustion zone. That high temperature region, this Fe2O3 reduced by the coke also. Okay, so the reaction will be like this. Fe2O3 is reduced by even coke also into Fe plus, it reduces into FeO and a CO. Again this will be further reduced into Fe. Okay, finally here you can directly write Fe. Okay, and this CO is going top to reduce it. Okay, but this reaction is very less, mostly CO only reduce. And another second super point I want to tell you, this reaction which I am showing on the screen, which reaction? See the reaction. CO is reducing Fe2O3 into Fe, I told you, correct? and CO is the waste gas. But this is not a single reaction. Actually, this reaction takes place in 3 steps. Now I am going to show you those 3 steps. See, Fe2O3, first CO reduces that into Fe3O4 and CO2 gas goes out. Actually, this is a waste gas, okay? And Fe3O4 is a mixed oxide. It is a mixed oxide of FeO and Fe2O3. See, students, see, it is a mixed oxide of FeO and Fe2O3. See, here oxidation state is +3, but that is reduced into oxidation state of +2. And as usual, some part will be left. This is a mixed oxide. Now, again, some more CO reduces the left out Fe3. Already some part is reduced. The left out part also will be reduced. Now entire Fe3O4 converts into FeO. A little, I may maintain the speed so to cover this in a short time. You can put little slow or you can rewatch it. Again, here completely entire Fe2O3 from +3 state we converted into +2 state. Now what I am going to do is, again the CO reduces into Fe plus CO2 goes out. So what I want to tell you, this entire 3 steps will take place. We have written in one step. Oh, we have written, because of my saree it's erased. So entire 3 steps I have shown you in a single step. That's why in a textbook, if you see all these steps mixed at different zones, you will feel confused, okay? But this video is an awesome video. If you find all my efforts are useful for you, please take a second of your valuable time and hit a like to this video and let me know in a comment section how was the class, and is it helpful, or what are the topics you are feeling little more difficulty. If you mention in the chat box, and if you let me know how is my class, I feel very happy. It will be a boost for me to do more best videos for you all. And questions which and please, if you are watching for the first time, please subscribe to Komali Mam channel. I have uploaded so much good content over the channel. It really worth of your subscribing Komali Mam channel. And see, I have shown you the questions at the starting. In the next part, I'll give the solutions to that. You will just by seeing only, you will solve any question from extraction. Thank you so much for watching this video. See you in the next video with more best awesome topics. Bye all of you. Have a nice day.